human-made satellites were orbiting around the Earth in low Earth orbit, or LEO, at the beginning of the space age. After Sputnik, the first satellite launch in 1957, a gradual but continuous stream of satellites reached LEO, with 10 and 60 deployments yearly until 2010s. Since then, the rate has exponentially increased, with more than 1,300 new satellites entering LEO in 2020 and more than 1,400 in 2021. These satellites bear different functions, including navigation, communications, time synchronization, and the observation of our planet. However, hundreds of satellites are now swarming our planet, and many more are planned for deployment. As of August 2022, the European Space Agency estimated that the total mass of all space objects in Earth's orbit is more than 10,100 tons. Unfortunately, not every object is tracked and catalogued, and according to statistical models, there are 36,500 space debris larger than 10 centimeters as estimated to be in orbit. 1 million space debris items ranging in size from more than 1 centimeter to 10 centimeters, and 130 million debris ranges from more than 1 millimeter to 1 centimeter. Further, space debris problem is getting worse due to the behavior of various actors endangering operational satellites in orbit. For instance, in November of last year, the Russians tested a direct ascent anti-satellite weapon, which resulted in the destruction of one of their own inoperative satellites and the creation of a significant debris field. The original direct ascent anti-satellite weapon test constituted a crisis for long-term space sustainability. Furthermore, with the spike in cyber attacks against satellites in orbit, a particularly concerning threat is a cyber attack against two satellites that collide, or one satellite to collide with the International Space Station, destroying both and generating debris that renders that orbit permanently inaccessible. Nonetheless, debris fields are not the only catastrophic threats to our orbiting satellites. Let's not forget the Carrington event of September 1859, the first documented solar superstorm, when a solar coronal mass ejection hit Earth's magnetosphere, causing severe damage to the telegraph system. A solar storm of this size would create havoc, causing widespread disruptions and blackouts due to the prolonged outages of the electric grid's communication networks and, of course, the Global Navigation Satellite System, or GNSS. The 2012 solar storm was probably just as powerful, but we were lucky that Earth was out of the ejection path. Let's stop a minute and reflect. What would a day without space system look like? Well, without Global Positioning System, or GPS, movements would be significantly constrained. Without satellite data, navigation system would not function, and public transportation would be in turmoil. People and products, transportation by land, sea, and air would be significantly impacted. Without the time signals from satellites, power grids become unstable, resulting in failures and blackout with unpredicted effects on economies and societies. Without satellite communications, public services are hindered. Police, relief services, and armed forces communications are halted, with adverse effects on public interest, security, and defense. Without satellites, cash withdrawal would be impossible without time synchronization. And without timestamps, credit transaction and money transfer would freeze. Without satellites, financial systems would collapse. Without space-based capabilities, weather cannot be monitored and disasters cannot be timely managed. Without Earth observation satellites, the fight against climate change would be lost, and environmental degradation will continue to pose a threat. Without satellite technology, scientific and technological progress would be hindered, along with our ideas, ambitions, and hopes for a better future. A day without satellites, and that is not all. That is to say that without satellites, imaging, monitoring, and surveying, navigation, communications, and science and technologies demonstrations are halted, and all our activities relying upon the related capabilities are limited or no longer possible. That is why space sustainability matters, to ensure the long-term enjoyment of space so that sustainability on Earth is maintained.